Andy from narcolepsypumpkin.com. Just want to have a little chat about unit testing and what the different types of implementation we use just for tests are. Right, so what I want to have a little talk about is unit testing, use of fakes, the use of mocks, and the use of stubs. Okay, there are some fairly subtle differences between the different types of implementation we use just for testing. So these are, if you don't know, are objects that are implementations of or imitations of real objects within the system when it's running live. And these implementations are designed just for using in tests. So it means we can cut off bits of the application and just test little bits and pass in these different objects to allow us to complete that test and assert that this little bit works. So what you're basically doing in tests is you've got this window that you're looking on that you're testing, and you're moving that window around by changing the bits that you're actually mocking out and the things that you're creating fakes for and the things you're passing in stubs on. So you're moving the boundaries of your test along to test each individual granular part of your system. Now, a fake, just like a fake watch, will work perfectly. It'll do the job. It will be, for the majority of the time, undetectable as a fake. It's going to be functional in the same way as the real object is. It's going to act and calculate anything that's designed to in the same way as the real implementation would do, but it's not the real implementation. And the big difference is, like your fake watch, so if you've got a fake Seamaster watch, that is going to fail under pressure. So you go diving with that watch, you get down to 2-3 meters, that's going to start letting in water, it's going to break, it's going to stop functioning like a fake. Well, it's going to function like a fake, in effect it's going to stop functioning like the real thing. The same is majoritively true of a fake object. That's going to, when you start putting loads of load on it, the cracks are going to start to show where that implementation is just done in the easiest way to do it for that test. It'll still work, but you'll start to see huge performance issues potentially. So why would you have a fake? Mainly, you're going to use a fake to have to enable you to test something that's a very broad test of your system. So you're almost one end to the other in some cases. A mock. So on the same line as a fake, so if a fake is like a fake watch, a mock would basically be a picture of a watch that you have tattooed on your wrist. Every time you looked at it, it would tell you the same time. It might fool the odd bit of code, but it's the real implementation, which is what it's designed for. You tend to have a mock done specifically for a test. You wouldn't tend to share them, so you're going to have a mock that returns just the right amount of information that allows you to test something. So it doesn't need to have anything further behind it. It's got no downstream dependencies. It's just going to return what it's been told to return, and the test will go, what time is it? It'll look at its tattoo and tell you the same time every time, but that's good enough for the inputs for the test or the outputs for the test or whatever you need it to do. Also, it allows you to do a test that's on a particular path that only uses part of that object. Again, if you're finding yourself with a lot of implementations of a mock where more than 50% of the actual properties or functions on that mock are just throwing a not implemented exception, and that's fine for your test because they're not really using them. That is starting to flag. I mean, certainly would to me that there's a chance for doing some interface segregation there and actually splitting that object up into, I mean, the implementation for live can stay the same, but you can certainly split the interface that's implementing it into more than one chunk, which will allow you to do those tests at a more granular level and sort of have more specific mock objects, possibly even getting those to be fakes in effect. So a stub. A stub is just as little, absolutely as little as you can get away with implementing to get it to compile, to pass in as a dependency for something, for a test that doesn't really use it. Now, there's an argument there that if you're having to do a lot of these, certainly for complex objects, there's a line you can find somewhere in there that this stuff isn't really needed, because that test isn't depending it. The code path you're testing doesn't depend on it. Therefore, there's an argument that there's quite a large chunk of that object does not depend on it. Obviously, if you're testing at a function by function level, again, that's sort of saying that you may be instantiating and depending on too much just to do little things.